What exactly are window functions? Simply put, window functions perform calculations that normally you would have to provide an aggregate for within the detail of your data. So, for instance, you could provide a running sum over all the rows that you show within your query. You can provide the average for the data set within the specific criteria that you've specified within your window function on each of the rows. I'm going to give you some very practical examples of how to use that data later on in the course. Some basic outcomes of a window function. You can provide a running total over all the records within your dataset. You can provide a ranking. So, for instance, you may have sales reps within a certain department that you need to rank based on different criteria. You can, again, provide averages, min, max, all of the normal aggregate functions. In addition, there are some advanced window functions like lead and lag that we'll cover as we get into the video. So I hope you're as excited as I am. I love window functions. Let's continue. So one of the things you might be wondering, I know how to create aggregations. I know how to take aggregations and apply them to another detailed query. But I bet you're doing it using subqueries and some maybe less efficient methods than using window functions. I'm going to tell you about some of the advantages of window functions now. One of the advantages of window functions are simplicity and readability. Window functions are just easier to read and understand what's going on. In addition, they provide some enhanced performance that subqueries just don't provide. When you have to create a subquery and then join it to detailed data, you're losing a lot of efficiency there. Within the join, within the subquery itself, this will eliminate that overhead and provide a faster and more efficient query. Third is some advanced analytic skills. So some advanced analytic abilities, Again, there's lead and lag that I'm going to talk about and some other advanced window functions. Are you ready to get into it and get your hands dirty? Let's go to the computer. The basic syntax of a window function looks like this. So you have your select statement, some column names, you have your window function itself, and it won't say window underscore function. It'll, for example, say average or lead or lag like we talked about. So within your select statement, you're going to have the column names that you want to include in your data. You're going to have the specific window function that you're using. The next piece is over. So you're saying I want to perform this function over this window. And we're going to provide some specifications of what that window is. We're going to say partition by, and it is exactly what it sounds like. We're going to partition or group by the specific criteria that we put in here. So we're going to select the fields that we want to group our window function by. And then we're going to say order by, and that's just the sorting order. So for instance, if you're doing a rank, you want to be sure to put whatever that sort order is. If you're doing a rank by performance for a sales rep over a specific metric, maybe over the sales over a given time frame, then we're going to say order by, and you're going to say whatever the dollar amount is for the field that you want to provide. So if your dollar amount is in a field called sales, then you'll put sales here. Then we're going to name our field. So we're going to use the keyword as, and then name the field. Remembering you can't have spaces in the name of your field unless you use square brackets around the field name. And then again, to complete our select statement, we're going to say from and the name of the table. Let's explore some of the most commonly used window functions. One of the most commonly used window functions is row number. This assigns a unique sequential number to rows within a partition. So, for example, we have this query that ranks employees within each department based on their hire date. Next, we have rank and dense rank. These are very similar yet distinctly different window functions. So the first one, rank, is one that we talked about briefly before. These functions assign rankings into the rows within the partition, but rank and dense rank handle those ties a little bit differently. The first statement, we have a select statement. Again, employee name and salary as the fields that we want to bring in. The keyword rank, beginning and ending parentheses to indicate the window function. The keyword over that we've been discussing. And then we're going to say order by salary descending. DESC just stands for descending. And then we're going to call that field salary rank. We're going to look at how we would write out dense rank. So dense rank, again, we're selecting the employee name and salary. This time we're saying dense rank over order by salary descending as salary dense rank. So you see the syntax is almost identical as rank, with the only difference being dense underscore before the word rank. The difference between rank and dense rank is going to be that rank skips ranks if there are ties, while dense rank will not. For example, if there's a tie for first place between 3 different employees, then it's going to show that they rank 1 for each of those first 3. However, on the 4th one, it's going to say 4. So it'll skip straight from 1 to 4. Next, when we look at dense rank, it won't. It will still provide the tie for the first 3, but the next set, if there are ties for the next place, then it's going to go to 2 instead. So you see the difference between rank and dense rank. So, I told you that we're going to look at lag and lead. These are functions that access data from the immediately preceding or immediately following rows without the need for self-joins. This comes in handy when you're doing things like creating slowly changing dimensions. That type 3 slowly changing dimensions where you need what the previous address was or what the previous phone number was within a data set, you could use lag. Lag gives you the preceding value for whatever that partition is. The syntax for lag is lag, the name of the field that you want to pull the value for, comma, how many records you want to go back. Normally this is going to be 1, so that you get the record immediately preceding the current record. Next, we're going to use our keyword over. We're going to partition by customer name. Again, we're going to say order by, and we're going to say date, and then whatever we want to name the field. In this case, we'll say previous address, because we're getting the previous address for that customer. Next, if we want to look at lead, lead will give us the following address. So, for instance, if we have a customer that's changed their address multiple times, then you may have 3 or 4 of them. You may, for the record, want to know what the preceding address was, what the current address is for that record, and then what the following address will be as that customer has moved multiple times. And then we're going to complete our select statement by saying from and then the name of our table. Now that you have a good understanding of the syntax of a window function, let's jump into some real-world examples of how to actually perform them within Azure Data Studio. If you don't have Azure Data Studio, be sure to check out the video about how to download and install it for free. And if you don't have a local SQL server so that you could do your practice, be sure to go out and get that as well. I promise some real-life practical examples. So, this is a practical example that you will use. In this case, we're taking a look at the employee table and the salaries. We have an average salary over department that we see right here on row 19. We're saying average salary, that's our aggregation, over partition by department. And that will give us the average salary by department. Sometimes you'll want to know what the variance is between the average salary and the salary of that employee. We're going to say salary and then the window function again. And that's going to give us the variance from the department average. Here's a bonus. I'm going to show you how to do a median in a window function. Median is not a normal function of SQL. You can't just type in median and use it as an aggregate function. You have to do it as a special window function. And I say special because there's an additional parameter here that you have to use. So we have percentile count, and we say 0.5. 0.5 here because that's what median means. It's the middle record when the values are sorted within group. So what this is going to say is when you put within group, this is your sorting. We're going to say order by salary descending. And then you're going to say over, partition by, whatever your grouping is. In this case, it's going to be department. So we want our median by the department. We need to put in the sorting order. So we say order by salary. And that's going to give us the median department salary. Next, we want to know what the variance is from that median as well. So we're going to say salary minus, and then we're going to say that window function again. And that's going to give us our variance from the department median. So when we run this, you see that we have the employee name, their salary, the department that they're in, the average salary by that department. So you'll see the same value for each of the engineerings, same value for each of the finances, human resources. You'll see the variance from the department average, your median department salary, and then the variance from the median. I want to show you one more thing, and that's going to be the output from the lead and lag query that we looked at a moment ago. So for the lead and lag, again, we have lag, the address, comma 1, because we want the immediate record before the current record. Partition by customer name, order by date will give us the previous address. And then we want for the lead, the same thing. The only difference here is that we have lead instead of lag. So it'll give us the next records data. And obviously we're labeling that next address. So I've labeled the address field as current address so that you could easily see which one the current address is, the previous address, and the next address. And we see down here in our results that we have everything sorted by date and by customer name. So we've ordered by customer name and by date descending. So we could see that this is our last update for Alice here. Her current address is 369 Redwood Lane. Her previous address was 258 Fair Lane, and she doesn't have a next address because that was the last time she updated her address. But you'll see that she's updated her address 3 times here, and you'll see that the middle one here has the current address, a previous address, and a next address. And obviously the first one just has the current address and the next address. And you see that repeated for the next few customers that we have in this table. So really cool function, especially if you're looking to create a slowly changing dimension type 3 and you want to have a before and after snapshot within each record of what the values are. So definitely practical use here for this. I hope that you got a lot out of this video. And if you have any questions about window functions, put them down below in the comments. I'm happy to answer them. And if you're interested in looking at our previous SQL tutorials, be sure to check those out. If you're looking to learn more about data engineering concepts, be sure to check those out. And if you are really enjoying the content, I hope that you like and subscribe to the videos so that you continue to learn more on your data engineering journey. Have a great day.